Welcome back. In the last video, we covered the topic of non-linear relationship and how to model them using ensemble models such as random forest, decision tree, as well as Adder-Boast. There is just one thing that I do want to visit, which is the feature importance. Now, this is something that we've covered previously under correlation as well as feature selection. But the issue then was that when we actually were performing the feature selection, we were using correlation analysis, but we don't necessarily know which feature is the best one to use. Remember too that we covered it again under multiple regression, looking at the coefficient itself, and also by looking at R-square performance evaluation by adding and removing features and see if the R-square goes up or down. So that's the other approach that we could take. Now this is the third one, which is making use of some of the model such as Adder-Boast, such as random forest, and in this case we won't demonstrate decision tree. So this is just another arrow into your bow that you can actually use to select the features that is most significant and make use of it to build your model, and allow these so-called ensemble model to inform you which are the important features. Now this is really following on from the previous lesson covering a brief introduction to Adder-Boast, random forest, as well as decision tree in modeling our Boston housing dataset. Now we have 13 features here. Are they all equally important? And which one, well, if they're not equally important, then which features are more important? Can scikit-learn help us to actually perform this exercise? Now we've already run the Adder-Boast and actually modeling our data using Adder-Boast ensemble method. So under Adder, the model itself, there is actually this feature importance where it extracts the so-called relative importance. All right, so if you have a look at the columns itself, these are the corresponding columns, although it's a bit difficult to actually directly correspond. So I'm going to use a data frame, pandas data frame, and just merge them together and name the column as features and sort the features. So based on this table, what you can see here is that LSTAT is the most important feature, followed by RM, this, and all the way down to the last three being age, ZN, and CHAS. It is pretty consistent with what we actually did before. Now this is just to help you to recall this. This is under the multiple regression, and what we did do is using the linear regression and using the actual coefficient itself to inform us, and especially after we have standardized it. So you can see LSTAT is also the highest here. It's consistent LSTAT. This and RM, this and RM, and the last three is H, ZN, and CHAS. This is using Adder-Boast. And if you look at this is age, Indus, and CHAS. So it's slight variation, but Indus is also fairly lower at the bottom. So they are fairly consistent. So if I plot that out, and what you can see here is that these first four really contribute a lot in terms of explaining the variability of the underlying median house price. So if we look at random forest, we can do the same exercise. If we plot that out, and what you can see here is LSTAT against the top, followed by RM, and then it taper down really quickly. CHAS, ZN are still the bottom. Age is about the middle, but they are still actually very small. So you can see that these lower portion here is just a small band. They seem to fluctuate quite a fair bit. But the funny part here is the DIS, right? It's actually quite prominent under Adder. Well, that's not funny, actually. It's consistent under random forest as well. Well, that's really the end of this video lesson. What I would like you to do right now is to actually, well, do this simple, really simple exercise. Run through this feature importance again, but the slight variation is this. Now, when we actually were doing the decision tree, we only select one feature to run our model. Okay, and what I'd like you to do is this time around run a decision tree with all of the X values, meaning all 13 features throw it all in and see what it looks like, okay, and see how the actual decision tree will plot out. And the second thing is, after you've done that, come down and run the actual feature importance and see if decision tree output actually agrees with what we have here. So take a few moments, pause the video now, and go and try this exercise. Right, how did that go? I really hope that you've tried that out and basically build your model using decision tree, regressor, fit using the X train and Y train data, same as edibles, and also random forest. Run the prediction itself, run the actual comparison between the mean square errors as well as the R square, and finally extract the actual feature importance itself. So this is my code. Allow me just run that for you. What you can see here, the mean square error is actually higher than both the random forest as well as the edibles. Okay, so for 1.87 for random forest and 4.48, where this one is in the double digits, so it's substantially higher. So R square naturally will be lower as well. And finally, in terms of the so-called features importance, if you have a look at this, you can see that RM is ranked as number 1, followed by LSTAT, and this is still the same 3. It's just that the so-called order is slightly different. It seems like for random forest and also this is edibles, agree that LSTAT is the most important, followed by RM and DIS, and but for the decision tree method, it seems to disagree in terms of the sequence. So that really comes to the end of this lesson on revisiting feature importance. I hope you have found it useful, and this video really highlight to you that there are multiple ways that you can actually extract the key features that actually have an influence over your model. So this is really one of the ways that you can actually tackle this issue and identifying the key features. With that, I'm going to end this video. Thank you for watching.